Today, I'm performing a full system evaluation on a Lennox split system. This system is currently operational, but testing shows multiple airflow and electrical concerns that, if left unaddressed, will shorten component life and reduce reliability. Biggest immediate concern. First and biggest concern, this furnace does not have a proper return plenum. Instead of a sealed metal box, a hole was physically cut directly into the air handler above the blower wheel. This is a major red flag because the blower is pulling in unfiltered attic air, dust, insulation, and heat. That contaminates the blower wheel, the coils, and throws off airflow balance. This alone can cause low airflow, dirty coils, higher electrical amps, poor comfort, and premature motor failure. Inducer motor and airflow restriction. The inducer motor is currently overamping, which means it's working harder than design. It's no longer operating efficiently. Combine this with low airflow, dirty components. This creates stress on the furnace during heating. Dirty coils and dirty blower wheel. Now, we don't clean these for appearance. We clean them to restore airflow, lower amp draws, and protect motors. This will also help with compressor life. Electrical component failures. The contactor and the capacitor are no longer operating within tolerance. When these parts run like this for a long period of time, they cause unstable voltage to motors that leads to overheating, overamping, and sudden breakdowns. The condenser fan motor is overamping. This motor is currently running between 1.02 and 1.10 amps, and the maximum rated is 1 amp. That tells me the motor is already under electrical stress. There's a chance that replacing the capacitor and the contactor will help bring that amp draw back into range, but there's also a strong possibility the motor itself is already deteriorated. Refrigerant pressures can look misleading when airflow and electrical components are failing. Before adjusting or assuming refrigerant problems, we must correct airflow and electrical issues first, so we're working with accurate system data. Because it's winter, labor rates are lower and parts availability is better. Preventative repairs now are far less expensive than emergency repairs in summer. When systems are under maximum load, recommended game plan: first step, build a proper sealed return plenum. Second step, clean blower wheel and evaporator coils. Third step, replace capacitor and contactor. Fourth step, retest condenser fan motor amperage. Fifth step, replace the condenser fan motor if, after all, remains high. The goal isn't to sell parts. The goal is to stabilize the system, restore proper airflow, reduce electrical stress, and prevent a breakdown when it's 110 degrees outside.